Okay. All right, so we come across this one, and we get to looking at this thing, and of course, this one's already specified out. I'm integrating with respect to y first, as it is showing right there, right? Okay, well, the problem with that is, if I integrate this with respect to y, the x cubed is fixed. I'm just integrating, I've got e to the y cubed. I've got e to a power of y, and I don't have any other y running around here. So it's not u substitution, it's not integration by parts. That's an impossible integral to do, all right? So that's sometimes what you run into, is you run into an impossible integral, and so the trick is that might be, I mean, it doesn't always work, but one possibility is switch it around. So instead of doing the y's first, let's do the x's first. Now, there's a little more to it than just switching those and then switching those. That's not what you do, okay, unfortunately. Here's what you do, okay? So what you first need to do is, all right, so let's draw out my region D here. So what would region D look like? Well, region D, I'm doing the y's first, so this is saying I'm going from y equals x squared, right? So y equals x squared to 9, to y equals 9. That's also y equals 9 because I'm doing the y's first. So I'm going from y equals x squared to y equals 9. And then my x's go from 0 to 3. How do you look at that? Then I'm doing this little, see that? So you just kind of work your way backwards here. This describes, you know, the limits here, that describes this region D. So you got to recreate that. And so that's when I was going here to here. That's what these did. So now I want to do instead region D, I want to do the same area, if you will. But instead of going from the y's, this y to this y first, I want to go from this side x to this side x. You see what I'm saying? Now, what would this be in terms of x equals what? X equals 0? That'd be x equals 0, so that's good. To this side, what is the x equals here? Well, it's just this one turned around, if you will, solved for x, right? So instead of y equals x squared, I got the square root of y equals x. X equals the square root of y. See that? So that's what I want to do for the x's. When I do the x's first, I'm going to go from 0 to the square root of y. So this is going to be, now, I'm going to do x cubed e to the y cubed, but I'm going to do the dx's, the integrate with respect to x first. And so that would go from 0 to square root of y for the x's. And then do my y's. Well, what do my y's go between? Well, that's just a number, so I go from 0 up here to 9, right? 0 to 9. So you see what I did there? Switched it around. So it's not, I mean, not hard, but it's not just an automatic thing. You gotta work your way through it, but just okay. Now, this is a much better setup because look at that. Now I'm going to integrate with respect to x first. This is a constant. All I have to do is power rule. I can do that. Hopefully I can do that. By now anyway. So it's just e to the y cubed. That's just constant. Power rule, so that's 1/4 x to the 4th. And that goes from x equals 0 to the square root of y. And I'm going to do the dy's once I figure all that out. Yeah. So this is doable. What do we got? E to the y cubed times 1/4, let's do it 1/4 in front here. All right, so we plug that in for x. So I've got, again, I've got the square root of y to the 4th. What is that going to be? However you want to, but one way, I guess you could, another way you could think of it, you got y to the 1/2 to the 4th, so you multiply, you got y squared. However, we did it a different way before, but it's y squared when you plug that in, right? All right, then we plug in the x to be 0. Well, that's good, because that's just equal. So all we wind up with is 1/4, however you want to write it, y squared, either y cubed, or leaving that way, but that's what we got. Now, we're integrating with respect to y, which we couldn't do earlier, but now that we've done the integrate with respect to x, look at what we can do here. What can we do here? What's going to work here? U sub, yeah, U sub's going to work. Because I have a y squared in front there. U equals y cubed. And so du would be 3y squared dy. So divide by 3y squared. And so that's going to be the integral now, 1/4 y squared e to the u, because that's what I call u. And then dy is d over 3y squared. Yeah, that's going to work out really nicely. Y squared cancel. So just have 1/12 e to the u. Well, e to the u, e to the u. So that's 1/12. Go back, because now these, I didn't write my limits, but these are y. Y equals 0, y equals 9. So I need the, instead of u there, I need y. So go back to the y cubed, e to the y cubed now. Now I can go 0 to 9, which is going to be 1/12. E to the 9 cubed, 729, minus 1/12 e to the 0, which is 1. So it's just 1/12 e to the 729, minus 1/12. Yeah, that's what I was thinking it was. That's right. Let me show you one more of those, and I'll be done for today anyway. Is that okay? Any questions? Problems? All right. One more of these version of integration examples. So that one wasn't too bad. You know, some of these integrals are worse than others. I think this one's too bad here, but okay. So integral 0 to pi over 2. Then integral 2y to pi, sine of x over x, dx dy. So in this case, I'm integrating with respect to x first. Well, we may have talked about that before. Again, that integral, not doable. Sine of x over x, anything you could try, it's not doable. Okay, and so that's, if you run into that, that's where, well, what about reversing the order? Can I reverse the order? So let's try that again. So first step in reversing this order, draw out the d, and then see what in reverse it would be looking like. All right, so in this case, I'm doing the x's, so I go from x equals 2y to x equals pi. Well, x equals pi, I know what that is. That's just a vertical line. X equals 2y, might be better, y equals 1/2 x, divided by 2, to draw it out. So the y-intercept 0, and then rise to run 1 to 2. Rise 1, run 2, okay, so it's, there you go. And then the y goes from 0 to pi over 2, so I'm talking, and just so happens that that corner there is where pi over 2 happens for y. Yeah, so this was, I did the x's first, so I went from here to here. So to change the order, I want to do, instead for d, I want to do that same area region. But I want to do from this y to that y first. Well, this is easy. That's y equals 0. And then this is, we already said it was 1/2 x. And so the y's are going to run from 0 to 1/2 x first. And then the x's would go from 0 out to this, which is pi. Easy enough. So do the y's first. You're going from 0 to 1/2 x. Still sine of x over x. But now I'm doing the y's first. And then the x's just run from 0 to pi. So we'll do those second. But you see that now allows me to at least start it. I can do this integral right here with respect to y, because these are just constants, right? So the antiderivative of that would be, so we got 0 to pi. The antiderivative of that, those are just constants, that's just a number. So it's just sine of x over x times y, right? And then do that from 0 to 1/2 x. Well, you can see how this is going to work hopefully now, because when I plug that in for y, I got 0 to pi sine of x over x times 1/2 x minus, and then good news on this is y is on the other part of 0, so that just goes away. Oops, forgot my dx. And so now I'm in good shape, because it takes out the problem here, because now, look at this. That's just 1/2 sine of x. You know, you still could, when you switch them, you still could run into some problems of integrals, because, you know, integrals can get complicated. Sometimes they're impossible to do, but sometimes switching the order works out nicely. In this case, there's another one. Let's see, the antiderivative of sine is negative cosine. So you got negative 1/2 cosine of x. Then we're going to go run that from 0 to pi. So I've got negative 1/2 cosine of pi minus 1/2, sorry, minus negative 1/2 cosine of 0. Cosine of pi, plug it in, but isn't that negative 1? Cosine of pi? Negative 1. Plus 1/2 cosine of 0 is positive 1. Hey, look at that. 1/2 plus 1/2. It's 1. Wasn't that what you were thinking when you started? It's got to be 1.